Welcome back to the Defense Tech Podcast. I'm your host, Civilian Sydney. If you've listened to this podcast before, you know that every episode features a subject matter expert in the field of defense technology, and that expert walks me through a topic from the ground up, whether it be new technologies, acquisition and government contracting, or general U.S. defense needs and plans of action for securing our country. This week I had the pleasure of talking with Brett Hamilton and Jalen Rollins from the Applied Research Institute, also known as ARI, who help lead the Silicon Crossroads Microelectronics Commons Hub. Brett serves as Senior Vice President of Microelectronics and Advanced Technology Strategy at ARI, and acts as one of the SCMC Hub leads. Brett is a respected national microelectronics leader with a 27-year career at the DoD, which includes serving as Acting Principal Director for Microelectronics in the Office of the Deputy CTO for Critical Technologies at the OUSD R&E. Jalen is the Innovation Program Manager for SCMC. Like me, he doesn't have a background in defense technology, but found his way through digital marketing and now leads impactful campaigns for ARI and the SCMC Hub. Jalen earned a degree in marketing from Indiana Wesleyan University, and as Innovation Program Manager, he leverages his expertise in innovation methodologies and industry trends to drive impactful initiatives. In this episode, we get into technologies such as electromagnetic warfare and discuss membership and hosting ideation activities to garner innovative ideas and foundational elements for successful integration of technologies and more. I hope you enjoy the episode. Hi, Jalen and Brett. Thank you so much for joining the podcast this week. I'm so excited to talk about your hub and your capabilities and get to know you guys more.
Hi, Sydney. Nice to talk to you as well.
Will you guys be able to start out by telling us a little bit about yourselves and your experience in the defense tech industry?
Okay, I'll start out. So I'm formerly DoD, retired from NSWC Crane after 26 years, specializing in microelectronics. I started out in rad hard and component test, and then moved up through anti-tampering and eventually trusted microelectronics. The last few years, I've supported DoD, and towards the end of my career, I was the acting principal director for microelectronics, the position that Dr. Shenoy has now.
Okay, awesome.
So after I retired, I joined ARI and technical lead for the Silicon Crossroads Hub.
Great. Good to have you. All right, how about you, Jalen?
Yeah, so my career's not been as long as Brett's, but I'll start kind of how I got into the defense industry. I actually, before I got into the defense industry, did graphic design and was reached out to by a defense contractor here locally to help design technical manuals for the Marine Corps. So I basically retraced all the images. Got into defense work that way, and then after several years, actually ended up moving to NSTXL, where I was there at the Smarts Collaboration Center. So did that for several years, got into more of the innovation processes and kind of methodologies, and then about 2 years ago moved here to ARI to help run several different things, but one of those is the Commons Hub that we were awarded.
Yeah, exciting. So as you mentioned, you guys are both involved in the SCMC Hub, the Silicon Crossroads Microelectronics Commons. So it's one of the 8 hubs obviously awarded under Microelectronics Commons last year in 2023. So can you guys tell us about your hub and how it came to be?
So the hub is basically composed of 3 states as the core regional portion of the hub, Indiana, Michigan, and Illinois. And within those, we have a core group of universities we call the R1N. So that's composed of Purdue, Notre Dame, University of Michigan, and University of Illinois, Champaign-Urbana. Those also compromise one of our major efforts. It's called the R1s that we may get into a little later. But we also have other universities that participate as well. The other aspect of it is the small business within the region. So when we started the hub originally, the first call for projects, we had about 130 members. We're currently up to about 250 members. Nice. A lot of those are Midwest, but our cores, our defense contractor partners, some of the national assets are distributed throughout the country. So it is regional in nature, but it includes and encompasses national reach.
Okay, great. That makes sense. Could you guys walk us through what your hub's mission is? Like, what do you hope to accomplish with the SCMC Hub?
Yeah, I can add to that kind of what Brett just said. Our main mission is to create a microelectronics ecosystem of those diverse partners that Brett just talked about, small businesses, government, academia, labs, primes, and how we impact that on a state, regional, and national scale. And we do that through workforce development, infrastructure, and various other different things. And then, all together bringing that in to attract national level talent.
Yeah, absolutely. That sounds great. So what are your guys' tech areas that you focus on? What does your hub specifically bring to the table for these DoD critical tech areas?
So from the onset, we have addressed all 6 of the technology areas.
Okay.
When we, in the first call for projects, we were allowed to submit 15 projects. And of those 15, we had projects in each one of the 6 technology areas. We were awarded 5 projects in 4 of the technology areas. So we're still actively engaged in all the technology areas. And one of the things I'll get into a little in some of the future questions is our hub model and how ME Commons funding is part of it, but we're also looking for other funding sources and other cost-sharing sources for long-term sustainment of the hub.
Yeah, absolutely. That makes sense. So as you mentioned, I would love to hear about some of the projects that SCMC was recently awarded in the first call for projects. Would you be able to give me a brief summary of each of them?
Okay, so the first project is titled I Am Crypto. It's an efficient hardware crypto engine based on in-memory computing. It's led by the University of Notre Dame. The team includes the University of South Florida, Analog Devices, RTX Corporation, and NSWC Crane. So I Am Crypto seeks to fabricate and assess a cryptographic accelerator that offers enhanced security and orders of magnitude improvement in key metrics such as throughput, energy consumption, and latency. This technology is built on previous concepts supported and developed by DARPA and SRC under the Joint Microelectronics Program, or commonly referred to as the JUMP program.
Okay.
Our second project, a digital direct waveform synthesizer, we call it DDWS, with integrated ADC functionality and enhanced security, is led by HII Mission Technology. The team includes Purdue University, Marvell Government Solution, Enhanced Semiconductors, Air Force Research Lab in Rome, and NSWC Crane. The DDWS seeks to develop first broadband digital direct waveform synthesizer that is highly programmable, offers high-speed communication links, direct data acquisition for flexible processing, secure storage, and the ability to create a root of trust processing environment. So that one, I guess I should say the technology area. These first 2 are under Secure Edge.
Okay.
The next one is under AI. The project is called Cheetah, or CMOS plus MRAM hardware for energy efficient AI. So that one's led by Purdue. That was a mouthful. That was led by Purdue. The team is the University of Michigan, Georgia Institute of Technology, Everspin Technology, Northrop Grumman Corporation, Argonne National Labs, and SWC Crane. So Cheetah seeks to develop a neuromorphic with in-memory computing to overcome the von Neumann bottleneck for MRAM, or higher density and energy efficiency that enables a new generation of robust energy efficient AI. Cheetah's design exploits the integration of MRAM and CMOS to synergistically combine non-volatile, zero standby leakage, high density, and radiation hardened into a single device. So you can see these are really super technical projects.
Yeah.
And all of our projects are leveraging previous work that got them up to the TR level that they're at now. And that's really important because this isn't a research project. These are prototypes that, once successful, will be ready to be qualified and transitioned into DoD programs. So the next one is under the EW category. The project is called High Performance Diamond Electronics for Next Generation Defense Systems. It's led by Great Lakes Crystal Technology, which is a fairly small business here in the Midwest. So it's nice that we do have a variety of leads for our projects across the projects. This project includes the University of Illinois at Urbana-Champaign, Purdue University, University of Notre Dame, GE Aerospace, Penn State University Applied Research Lab, Army Research Lab, and Navy Research Lab.
Oh,
the
lots
project,
involved.
Yeah, most of our projects are at least 4 or more members, and most of them include academia, a small or large business, a defense partner, and a government lab. And we did that on purpose. When we were doing the call for projects, we offered up meetings, and I had 60 meetings with project proposals, and we went over, what makes up a good team, what's the government going to be looking for, and really it's all about capturing technology that's been proven, but very importantly, having a transition path. Ultimately, in my mind, ME Commons is about delivering something that is transition and available for DoD, whether it's a DoD specific application or dual use where you're leveraging commercial building it, but it is something that DoD needs.
Yeah.
So for this project, the primary objective is to develop a new generation of diamond-based high-power radio frequency transistors for future electronic warfare systems, and associated power transistors condition the sensored prime power. The secondary objective is to increase the size of the device quality diamond wafers, which will support lower device costs and higher volume adoption potentially. So that second part's talking about the wafers. So basically scaling up the size of the wafers.
Great.
The 5th project wasn't one of the ones that was originally announced. So some people might not even be aware that we have a 5th project. And the name of that project is Improving Engine Reliability and Swap with 350 to 500 degrees C silicon carbide electronic systems. It's led by the University of Michigan. The team includes Ozark Integrated Circuits, GE Aerospace, Wolfspeed, and NASA Glenn Research Center. And the project seeks to establish and demonstrate high temperature, as I said, 350 to 500 degrees C, which is quite a bit higher than the current is around 250 for the max. Silicon carbide-based integrated circuit technology process and companion packaging. And that's important that if you make these very high temperature devices, the packages can withstand that as well. This US-based process will be commercially available while also enabling specific next generation DoD system applications ranging from high temperature actuators for hypersonics to state-of-the-art turbines for fixed wing, rotary, and unmanned aircraft. So that's an overview of our 5 projects. I think they're great projects, and we're really looking forward to getting them kicked off here over the next month.
Yeah, congratulations. I think it's so interesting how very specific each of the names and descriptions are. Why do you think that is, that they have to get it so pinpointed for each project?
I think they really want to highlight the strengths of the research that got them to this point. And they are really addressing a gap that exists right now, either from a power consumption point of view or in the ability to scale and transition it to commercial.
Okay, so they want to highlight kind of, sorry, go ahead.
Yeah, so right now power is a huge concern across the whole industry because of the explosion of AI. And if you look at the amount of power that's being used in the data centers, it's just skyrocketing to the point where a huge percentage of the production of power is used for data centers. And so we need to develop more efficient microelectronics to help cut that down, because it's not going to stop. I think AI is going to continue to grow, and the data centers is a huge part of it.
Right, that absolutely makes sense.
So of the 6 technology areas, our 5 projects span 4 of them.
4 of them, right. Great. So speaking of the electromagnetic warfare project, would you be able to dive a little further into the utilization of that type of technology in the context of the Commons mission?
Okay, so that's an area where there are a lot of specific applications for DoD use. EW is a large area, and it encompasses a lot, from man packs that they wore for counter IEDs over in the Middle East, clear up through, aircraft EW, ship EW, vehicles, ground vehicles EW. So it is a huge area. And luckily, Silicon Crossroads Hub is here right next to NSWC Crane, who has one of the largest workforces in EW of any DoD lab. So we work closely with them. But for the ARP specific project, it really is focusing on increasing power while reducing the size and weight. So you hear SWAP, size, weight, and power. That's exactly what this is doing. So one way that diamond is able to do that is it's a very good conductor of heat. So as you cram stuff down into smaller and increase the power, then you can figure out how to dissipate that heat from the package. These kinds of technologies do have applications in the commercial world. So for example, this one could potentially be used in transmitters for cell phones, cell towers, things like that. Those 2 areas, commercial or EW and 5G, 6G, has a lot of overlap, because a lot of it has to do with increasing the power and reducing the size and weight for the system, whether it's in a cell tower or in a drone.
Yeah, absolutely. Having a diamond in there makes it a really classy semiconductor, I feel like. That's cool.
Yeah. It's pretty cool technology. And the other interesting thing about that one is it was actually plussed up, or additional funding was applied by DIU. So the Defense Innovation Unit, who is another big arm to really leverage the commercial sector and accelerate technology, picked this one as one of the ones that they wanted to help accelerate. So that's a good success story from our hub, where we are already beginning to leverage other funding sources to help accelerate the projects that we've started.
Great. So we touched a little bit on how your hub is working to solve like the electromagnetic warfare critical technology issues for the DoD. Could you help explain a little more how this will help to re-onshore microelectronics manufacturing capabilities in the US in the long term?
Yeah. So one of the projects, and I won't get into the specific details because I don't want to get anything proprietary, but one of our projects is actually working with a very large company to help reshore some technology that's currently offshore. So that's a good example. And the challenge with DoD is their low volume in general. So they don't really drive industry. But one thing that's helping is the CHIPS and Science Act, large investments to a lot of companies, and some, mid-size. There's, it's TSMC and Intel and Samsung and the really big companies, Micron. But then there are also quite a few awards down for middle-sized companies that Those are anywhere from 50 million to 350, 400 million. When those happen, those companies are more willing to work with DoD and help focus and enable access to their core technologies for our ME Commons projects. So working jointly with them, we will have more access into the technologies that are manufactured in the US because commercial volumes are huge. And if you look at these big companies, they're literally making hundreds of thousands of wafers a month, and DoD may need 2 wafers. So we really are a very small user, but I think a lot of what's going on with Microelectronics Commons and the CHIPS and Science Act in general is to help make it easier to work with these large companies. And the big focus of CHIPS, and I think they're doing a pretty good job of staying on focus, is how do we strengthen and expand domestic production?
Yeah, absolutely. That's really well said. So I would like to touch a little bit on commercial leap ahead as well, and that was that last project that you described that was added on a little later on. So would you be able to dive a little further into the utilization and development of the commercial leap ahead technology in the context of the Commons mission?
Yeah, so that's one, again, where the U.S. is really embracing electrification of everything. So you hear a lot about it with cars, naturally, but it's happening in industry. One of my neighbors works for Cummins, and a lot of the stuff that used to be diesel or gas is now electric. And if you think about it, for example, like forklifts in a factory, in a warehouse, all that equipment is basically going electric. So having the high power and the high temperature electronics to go along with that is really key. And one of the first things you look at in any of these electric vehicles or farm equipment or whatever it is how efficient is it? How long will the battery last? And that is really the key. So having more efficient microelectronics, and then this specific project is having the electronics that can operate at the high temperatures. So inside, one of these motors or inside an engine to make a traditional diesel engine more efficient, or a turbine or a jet engine, whatever it is, having the sensors right there enables a feedback loop that can drive efficiency.
Great, that makes sense.
So one of the teammates on this that I didn't mention because they're serving as advisor role is Rolls-Royce, which is a huge company right here in Indiana that does a lot of DoD business. So one of the things we look at on all of our projects is we have our core team, and that generally includes a potential transition partner. But we also bring in other people that we think will be users of this technology. They may not build it, but they would be the ones that would buy it in the end. It's very important to get their input in the beginning because that helps drives the requirements and make sure that it is something that they can use when it is finally matured.
Yeah, absolutely. I like the long-term vision in that. It's great. So I'd like to switch gears a little bit and touch on the aspect of workforce development in all of this. So why do you think the Commons program has made the aspect of workforce development such a large one in its efforts?
Yeah, so there's kind of 2 aspects to workforce development that we're looking at from the Silicon Crossroads Hub point of view. And we have 6 workforce development projects that were in year 1 that are going on. A few of them focus on the DoD specific workforce or enabling that workforce. So for example, one of our projects, we actually did a DD-254 and are sponsoring their clearances. So they will they're getting training, but they're also have a security clearance so they can go do an internship at a defense contractor. And that's kind of a big deal to do that earlier in their career rather than after they graduate. The other thing is we talked a lot previously about bringing stuff back on shore. To do that, you have to have a workforce. And right now, since so much of the manufacturing has been offshore, we don't have that workforce. So to be able to do that, if, for example, in our region, SK Hynix has announced that they're investing $3.5 billion in West Lafayette to build an advanced packaging facility where they'll basically package the parts that are used for the most advanced AI, like NVIDIA chips and things like that. That's going to take several hundred workers in that facility. A lot of the workers in these advanced manufacturing facilities are the same kind of workers that you would need for a pharmaceutical manufacturing facility like Eli Lilly might build, or an advanced automotive facility like Cummins might have here, or GM or Ford. So the competition for those technical people is really intense because all these manufacturing involves robotics, automation, and getting that skill set is what I'm calling the new blue collar jobs here in the Midwest. You know, traditionally, if you worked in a factory, you might stand and kind of do some repetitive thing all day.
Yeah.
Those kinds of jobs are really going away, and it's really turning more towards who works on the equipment that runs. And it's not just manufacturing, it's also warehousing. Everything's becoming more automated to cut down on labor costs and make them more efficient. And that really is the key to the U.S. being competitive globally. Because the more automated something can be, the lower the cost and then the more competitive we'll be globally.
Right. Yeah. Is there anything you wanted to add, Jalen?
We're pretty proud of the 6 programs that we do have. Like Brett said, you know, some of them are pretty unique and different. So we're proud that those are part of our hub.
Yeah, absolutely. Yeah. Congratulations on those. So is there anything else that you guys would like to highlight about your hub? That's about all the questions that I have for you, but I want to give you a chance to talk about whatever you want to highlight.
Yeah, Sydney. The one that I did want to highlight is our Silicon Crossroads Collaboration Center that we actually were funded for in year 1. You know, we wanted something for all of our hub members to be able to come and utilize, you know, if they have meetings, classes, whatever it is. So we actually took our existing office and built out the remaining back area. So that officially opened in June. So since then, we've had about 29 usages of hub members coming in, doing workforce development classes, hosting meetings, doing strategic type things. So it's been pretty busy since the opening. You know, the center's a little bit different. It's innovative. It's kind of fosters that collaboration, which is kind of what we wanted. So I wanted to touch on that. That is something that hub members of ours are open to utilize. And, you know, once we get to further questions, they can kind of figure out how to connect and how to use and request that space. But the second one I wanted to talk about was our ideation event that we held back this summer, right around the call for topics time. You know, that was kind of an inaugural event that we held. We wanted to do something different that brought the hub members together to throw out ideas on the wall and see what we could come up with. So we did a 2-day event with about, I think 150 members were there. We brought in a third-party facilitator to help us kind of facilitate ideation and just off the wall thinking. We actually ended up over those 2 days coming up with 32 ideas that people actually put on paper. So I know 32 may not seem like a lot, but it actually was quite a bit. And they were what, Brett, probably a couple pages in length. So they were pretty good content wise.
Yeah. And a lot of those fed into the call for topics that we submitted a month or so later. And that was kind of the idea, to help generate ideas based on a diverse set of people coming together and doing this ideation event.
Yeah, I know a lot of the ideas that people did come together on were probably teams that probably would have never thrown ideas together just because they weren't near each other. But since they were in the same room, in the same group, it kind of helped form those teaming, you know, engagements.
Yeah, it's fascinating what can happen when you just put a couple people together who normally don't interact. Yeah, that's really cool.
The only other thing I mentioned, the R1N network of our local universities. So if you look at those 4 key universities I mentioned in the 3 states, they all have very capable labs, including clean rooms. And in today's dollars, it represents about a $750 million investment. So it is really a powerful capabilities. One of the things that we've done across those 4 groups is a joint user agreement. So if an industry partner or a university partner wants to use multiple labs, there's a joint agreement between the labs being put in place that enables you to move from one to the other. So it's all the legal stuff plus the training. So each lab might have some specific training, but general clean room training, you take it once, you don't have to retake it every time. And we figure that's going to shorten the time to go from one lab to the other by many weeks. And if a company does it, it's good for the company, not for individual users as far as the legal agreement. So that's, as best we understand, the first in the nation of doing that and getting this formal agreement that really allows access to the network of hubs. So as part of that, we have a website, www.siliconcrossroads.us. On that website, we will have a link to that network that shows all the equipment they have. So if a small business wants to get access to a specific piece of equipment, they can look on there, find which lab has it, go to that lab, get the required training, and either have the university do the work for them or actually go into the clean room themselves and do that work. So when we were doing a study on what do small businesses need for venture capital or to get started, access to equipment for microelectronics was a big one because it's very capital intensive. I mean, like I said, those labs, it's a $750 million investment. Well, there may be a piece of equipment in there that costs $3 or $4 million. A small business can't go out and buy that. And to be able to get access to a big industry partner, they don't really want to mess with the small businesses in generally. So having this to the universities, I think, is really a good way to do it. So we think it's a really good model, and that is part of our funding to support that R1 collaboration going forward. So I think that's all I had. Anything else from you, Jalen?
No, that's it.
Great. So you mentioned your website. Is that the best way for someone to get connected with the hub if they're interested in becoming a member or just getting involved?
Yeah, that Brett mentioned siliconcrossroads.us. There is a tab at the top for getting connected. So literally all you'll do is fill in your information. You'll get an email from someone on our team. We post a lot on LinkedIn. More than welcome to follow us on there to kind of see what we're doing and maybe some of the success stories that we're posting.
Yeah, absolutely. Sounds great. Well, it was great talking to you guys and getting to know more about your hub. Thank you so much for explaining all that and saying those big mouthfuls of project titles. Really appreciate it. And yeah, just thank you again for coming on.
All right. Well, thanks for the opportunity.